All right, so starting to record now. We've got section 7.4, talking about inverse relations, how the inputs and the outputs will switch. The domain of one will now become the range of the other. So if this is our original function and I'm looking at the domain of the original function, notice what happens when you look at the inverse function. The table's range. So the inverse's range matches the original's domain. So I want us to circle the domain in the original matches the range in the inverse. And I'm going to use a different color to just make a note. Notice how the Y column in the original matches the X column in the inverse. So now what we're going to do is we're going to use some colored pencils for this. We're going to look at what happens with an original relation. I need this in one color. The original relation needs to be in one color because color didn't show up on your notes. And we need it to pop out. So, the original function is going to be in one color. And that's my blue. And then, its image, or its inverse relation, is the dashed red piece. So here's what this is saying. Inverse functions will be reflections across the line y equals x. Because the domain and the range switch spots, all of these points on the original function, so like, for example, this point of 1, what is it? Oh, this point of negative 2, 4, I believe. Negative 2, 4 now becomes 4, negative 2, because the x's and the y's change. So graphically, all inverse functions will be a reflection across this perfect diagonal in a coordinate plane. So again, this original blue function, if you look at its inverse, it's going to be a reflection across that perfect diagonal y equals x. That's how they look graphically. So in a table, you'll see the x's and y's change places. In a graph, you'll see that, hey, wait a second, they look similar, but they're sort of reflecting across that y equals x line. Now let's go to algebra. Here we go. Flip over your paper. How to find the equation for the inverse relation. You've already got this written down. I'm just going to review it. First, you got to write the original relation. Write the problem down. Then you're going to switch the x's and the y's. Then you'll solve for y. Special note, remember, f of x is the same thing as y. So here we go. We're going to find the equation of an inverse relation algebraically. First step is write the problem down. So hopefully you've already done that. Second step is you're going to switch the x and the y. Since the domain and the range, the inputs and the outputs change, you switch them. Ah, there we go. We're going to get rid of the constant first. So subtract 8 from both sides, leaving us with x minus 8 on one side and only 4y on the other side. Divide by 4, but when we divide by 4, we're going to make sure we divide the entire left side by 4. And then watch what happens with the notation in the end. Because I started out this problem with a y, my notation in the end is going to end with y inverse. So notice the language I'm using, y inverse. First way we could write our answer is by dividing each term by 4. So we get a fourth x minus 2. Or keep going. Or don't. But either way, notice how you have to keep the notation y inverse. I will take off points for not having the right notation. Next problem, y equals negative 3x plus 12. You got to write the relation down. Then, we're going to switch the x and y. Once the x and y is switched, now I'm going to move the constant. Move the constant. Now, in my next work, I divide by negative 3, different than how I divided by 4 in the previous example. You could divide each term, each piece by negative 3, and still get the answer to be either negative 1/3 x plus 4 or the other way. Hold on. All right, we've got one more problem. We're going to figure out the complete operation or the function that completely undoes what we're looking at. Taking 2/3 times a number minus 4. So to undo it, first switch the x and y. And then start solving for y. So add 4 to the other side. How do you undo 2/3? Multiply both sides by 3/2. I've got two choices. Distribute and simplify, and realize that we're now at the inverse of y. So this notation has to be there. It's just telling the reader this is how you undo the function. 3/2 x plus 6, or you could write it in the next form. So we're going to skip to example 6. We're going to try to figure out what happens when we have a power function. How do we undo it? So the first step is make x where the f of x is, and then instead of f of x, I'm going to change it to be a y. Wait a second. I hate what's happening right now. I hate the way that looks. Ew.
Can I write it as y?
Ew, I hate the way that looks. Hold on. So switch x and y. To undo this, we've got to divide by the coefficient first. Divide by -1 first. Getting negative x equals positive y squared. Now I can take the square root on both sides. When I take the square root on both sides, I insert a plus or minus. But then wait a second. This is what happens. This is the inverse function. So I'm not going to say y inverse because that's not what this started out. It started out with f. So I'm going to use the language f inverse equals, it says plus or minus the square root of negative x. But because this says the original domain is going to be negative, that now means my range should only be negative. So instead of the plus or minus, I'm only going to keep the minus.